All right. All right. We're live. Good evening, good afternoon, and good night. We're back again with the second workshop in our series as we're building for these next 2 weeks in the Innovation Sandbox. I'm excited for this one today. We're going to be talking with Goldsky, an indexing and data stream solution for your Near projects. I'm joined today by Andrew. Let me bring him on.
How's it going, everyone?
How's it going, Andrew? Welcome on.
Thank you. Excited to be here.
Yeah, we're excited to have you. How about you want to tell us a little bit about yourself and what we'll be doing today?
Yeah, definitely. So today I'm repping the Goldsky vest. I'm calling from San Diego, so vests are like pretty ideal versus a big warm jacket, So today we're going to be talking a little bit about, what is exactly indexing and how it can optimize your workflow. I think that there's a lot of different ways that you can, leverage on-chain data to either do analytics or power your dApp. And we're just going to talk about how you can use Goldsky to do that. And a little bit about me, I'm the customer success over at Goldsky. So I basically, just try and figure out what the developers are doing, how we can engage with the ecosystems and just make it easier for all of you to build. So part of that is doing little workshops like this just to teach you, some cool tips and tricks.
Awesome. Well, we're excited to have you here. Love the energy. This is great. I'm going to go ahead and bring up your presentation now, and I'll come down and then take it away, Andrew.
Awesome. Sounds good. Thanks, Elliot. So yeah, this is basically Goldsky 101. So if you've never been building before with indexing, or if you're a professional, data analyst, either way, Goldsky has a solution for you where we basically make it really simple to get started if you're just learning how to index, or if you really want to get custom and get really into the weeds, then that's a possibility as well. But yeah, let's dive into it. So as mentioned, I'm on the customer success team. So yeah, just really excited to just figure out what everyone's building and how we can make it easier for them to do that. Now, just to give you a quick recap of what we're going to talk about. So today we're going to touch on A, what indexing even is, B, what subgraphs are, and then C, what mirror is. And at the end, there's going to be a little sneak peek into some kind of new thing that we've got that I wanted to just give you a little alpha on. It's our next gen pipeline engine. So stay tuned for that. But basically, just at a very high level, what we're going to talk about with indexing is essentially the benefits of indexing on-chain data rather than just doing direct RPC calls. Subgraphs, just to give you a really high level, that's a customized GraphQL endpoint that you can query. This is probably what most of you have heard of. And in general, when it comes to indexing EVM chains, this has been the standard approach. And then mirror, this is where we're going to be diving really into the, the Near data sets and showing you how you can index Near, but real-time data streams directly to your database are at the very high level what mirror is. So let's dive into indexing. So essentially, whenever you want to look at on-chain data right now, let's say you do an RPC call, it can work for very limited things, but oftentimes there's going to be complicated block data and the RPC call is maybe inefficient. And especially as you're scaling your app, whether you want to get to the size of Polymarket or you want to be the next big, trading platform, DeFi, whatever it is you want to do, whether it's real world assets, want to get into stable coins, when it comes to scalability, you're going to really want to have your app and your analytics and all of your data just be really on point and, real time. So especially as we're going to be bringing on, all these people that are familiar with Web 2 speeds and Web 2 applications, when we're onboarding these new people to Web 3, they're going to be expecting Web 2 speeds. And a lot of the times you'll find as you're building to scale out your app that RPC calls cannot work in a fast enough capacity to basically give these Web 2 speeds that people are familiar with. So indexing is in a sense a way to really optimize for speed and efficiency so that you can get the data you need, whether it's for analytics or to power your app in a really efficient way. And to give a little overview of the differences between RPCs and indexing. So when it comes to RPCs, the query type is going to be more simple lookups, whereas indexing, you can have complex queries. And that's because in indexing, it's essentially these pre-structured, they're these data structures that are designed to be queried. So when you have complex queries or specific data that you're looking for, they're intended to be searched, they're intended to be used and indexing basically makes it more readable format for these queries. And as far as performance, because of how this structures, with RPCs, they're going to be often slow, and a lot of them are rate limited. So, even if they're fast enough, you get to a certain amount of, RPC calls, you're just going to get hit with rate limits oftentimes. And indexing is fast, query optimized, so it really is built to have performance. And believe it or not, even though indexing is the faster solution, it's actually lower effort. So RPC maintenance can often be a high cost for developers, and indexing is really simple. You just spin it up, it's quick to deploy, and there's not a lot of maintenance. So when it comes to scalability, effectiveness of decoding, doing aggregations, all of that is optimized and just a lot easier with indexing. So in general, indexing is just going to be a superior solution to RPCs when you're really trying to scale your app. Now, traditionally, when it comes to indexing, EVM chains have often relied on subgraphs. And just to give you a little context, because it's helpful to understand the history of indexing before we get into data streaming pipelines. So basically, the way subgraphs would work is you would index the network to essentially extract the data that's happening on chain. And then it's transformed into this more optimized structure so that it's got organized what we call entities to basically help you understand on-chain events that are omitted, or whatever's happening, whether it's a mint or a transfer, right? It basically transforms the raw data into these organized entities. And then with a subgraph in particular, that data is stored on chain, and then you get this GraphQL API endpoint that you query. And so typically, a lot of the time when people would build with subgraphs, they would have this endpoint, they would find the smart contract they want to get information for, and then they would query that. Now, subgraphs, although they are very powerful and, an improvement over RPC calls, they do have some limitations as well. And so that's kind of what was the need and the birth of Mirror on our end, is that as we were seeing all these projects hit new waves of scalability and just growing really quickly, we realized that we needed to create a new framework that can keep up. And so essentially that's what Mirror is. It's like the evolution of indexing from subgraphs. Mirror is the next thing. So basically with Mirror, it unlocks a lot of possibilities because of the way that it's designed. So recapping, with a subgraph, you've got this GraphQL API endpoint. You're basically calling that and then pulling the data. Whereas with Mirror, you're basically getting this on-chain data, creating this data streaming pipeline that real time pushes data, and it's going into your database. So a database like ClickHouse, Postgres, S3, right? So essentially what's different here is that the data is being streamed real time and you're querying your database directly. So that's going to be a lot more efficient, and it's going to unlock a lot of very cool use cases. And some of those include off-chain and cross-chain types of merging of data, where you not only just can, very quickly get the data from a specific chain, but you can now have multiple data sources. So you can combine, information from 3 or 4 different chains all into your database, and then you just query the same table and it's all in one place. So off-chain or on-chain, between chains. You can also do off-chain. So if you have, your own data sets or your own database or just some kind of other off-chain source that you want to rely on, you can do all that in your database, because of course your database isn't restricted to on-chain data. You're just basically using on-chain as a data source to put into your database. And then your database, you can then aggregate all the different kind of data that you want, whether it's your own internal data or another off-chain source. But essentially, Mirror unlocks a lot of possibilities because of the flexibility you have and you own the data. So Mirror is a very, very cool new innovation. And to give you some insights on some of the benefits, so real-time streaming to a database, that's just going to be very fast, and that's going to be almost instant. So basically, as events happen, they're just pushed directly to your database, and so it's updated real time. You have the full control over the storage of the data, because you don't have to query the endpoint each time. It's just in your database, and once it's there, it's already there. So you basically deploy a pipeline, backfill the data, and then once the data is backfilled into your database, you fully own it and control it. And then it's all just about maintaining, the stream where real time it's continuously updating, right? So it's a lot of benefit to have your own data, especially if you're trying to, make it really, really fast querying, where you just query the database. So that's a pretty cool benefit. And then, yeah, like I mentioned earlier, the multi-chain and off-chain data. If you wanted to combine data from multiple different chains with subgraphs, you would have to do multiple subgraphs. And that could get complicated really quickly. But with Mirror and with pushing the data into your database, you're essentially creating like a home base for all of your data. And so really what that means, all that together, it's designed for scalability and speed. And you're able to get, historical data, edge streaming data. And one way of looking at it as far as the scalability comparisons, subgraphs, it's kind of like a vertical scaling where you just kind of throw more compute at it and it scales vertically. Whereas with Mirror, it's horizontal scaling. So it's in a sense infinite scaling, and you can have a lot of things happening at the same time, and it can handle it no problem. So now I'm going to go ahead and give you a little demo of how to actually use Mirror in the Goldsky app. And if you haven't yet already, feel free to follow along in the demo. If you go to app.goldsky.com, you can sign up just with Google. It takes like a second, so you can follow along with the demo. But I would also suggest that you go to docs.goldsky.com/chains/near. So this is our dedicated page for Near, and it's a really, really good quick guide just to get started. It gives you some insights into, what are some of the benefits of building with Near data sets, how you can get started, from as simple as installing the CLI to, giving you an example of some SQL transform you can use, a YAML file you can use for the pipeline config. So this is a really, really good page just to reference for when you're getting started. But I'm going to go ahead and show you a couple examples. So when you are in the pipeline page in Goldsky, creating a new pipeline, super simple. You just hit new pipeline, and you'll find that there's two different versions. So for this first example, we're going to go with standard, and that's just like our typical Mirror pipeline. Turbo, this is that alpha I was telling you about earlier. This is our new product. It's the V2 version of pipelines. And I wanted to just first show you the standard version because we have a really nice aesthetic flow editor. And the turbo pipelines, that's going to be more like a YAML config file. So the visualization of the standard pipeline, it'll help you guys just kind of understand what's happening. And I believe in the future, we will make it so that turbo pipelines are a part of the flow editor as well. But this is all still super new. As you can see, it's got the beta flag. So turbo pipelines, they're pretty next level. But let's go ahead and get started with the standard pipeline. So this is the flow editor. It's really familiar probably to a lot of different editors you've seen. And so basically, it's as simple as dragging and dropping. So the first thing you're going to want to do is take your data source, drag that on there. And for this demo, of course, we're going to go with Near. And you'll see there's a few different data sets. So just to give you an understanding of what each data set is, it's basically types of data that we've pre-ingested so that it's even faster to push into your database. And the four that we have here, they're designed for Mirror V1. And then these three, they're designed for Turbo. So that's why they've got Turbo there. It's just the latest version of the data set. But yeah, for this example, we're going to go with execution outcomes. And we'll start indexing at the edge of the chain. So basically step one, super simple. You just pick your data source, you choose the chain, you choose where you want it to start indexing, and then you're on your way. So next step is going to be figuring out how we want to actually transform this data. So you have an option. You can just push all the data, just entirely of the whole chain, of the execution outcomes data set directly into your database. Or you can get super custom and actually create a subset of the data. And it's definitely encouraged to create a subset of the data because unless you need all of the data of the entire data set, it's just going to save you costs and it's going to be more efficient because you're going to basically funnel in only what you need to look at. So rather than, ingesting all of it, you can just customize it to specifically what you need. So there's two ways you can do that. One is custom SQL, another is HTTP handler. Custom SQL, that's, pretty straightforward. You just basically put in a query and it will filter it real time so that as the data goes through this transform, it's going to filter that before it goes into your database. Now, HTTP handler, that's a little bit different where it basically pushes that somewhere outside and then you can do the transform in your own way. This can be really custom, but basically custom SQL is the typical way to go if you're just going to stay in app. So I'm going to go ahead and click that option. And as you can see, there's this little pop-up window when you click into the query, and this is where you can pretty much modify it and customize it to whatever you want. So, and by the way, it references source 1. That's referring to this source. So just to kind of make it more clear, I'm going to rename this to execution outcomes. And then as you can see here, that got renamed there too. So pretty much this SQL right now, what it's showing is it's select all from execution outcomes. So the data set I picked, if I do nothing, it's just going to give me everything. But I've got an example query I wanted to run. And basically for this query, it's essentially just looking at any transactions that failed. So this is going to be a pretty cool way where if you wanted to use this example to debug, what's happening on chain, maybe there's specific things you want to monitor, and, outcomes that are failed are an interesting insight that you can take a look at. And so this is what we'll do for this one. So basically, once you add your SQL, you figure out, what it is that you want to filter it by. You can do run, and that will just go through just to make sure that everything checks out. So as you can see here, it went through each of the variables just to make sure that they're legit, everything is formatted correctly, and get me the green check. So basically I'm good to go there. But yeah, when you expand it, it kind of shows you what kind of data you're filtering for. So this is just basically the blueprint for creating the subset of the execution outcome data that you are ingesting. And quick side note too, you can do multiple transforms as well. So let's say you want to have, a second transform that filters it even further beyond this. You could do that as well. As far as sources, you can have multiple sources too, and you can even put all of them through a similar type of transform and then all go to the same table. So this flow builder, it's really, really cool because you basically get to visualize how the data is moving through. So, it's going from the source here, funneling into this transform, filtering here, and then next stop is it's going to be going into the sink. And the sink is going to be the database that you choose. So I already have one connected for the demo, but if you wanted to create a new sink, basically what you would do is choose from the available options. And all of these, just for reference, they're all great. It really just depends on what your use case is and what you want to prioritize. So some databases are more optimized for querying, a specific thing, whereas another, maybe it's faster in this way, or another, you already have all of your data for your application built there already. So you just want to keep everything in one place. So really, it just kind of depends. But the most popular ones we've seen are usually going to be Postgres and ClickHouse. So for this demo, I'm using Postgres, and specifically hosted Postgres, where it's not actually my Postgres, it's a hosted Goldsky Postgres. And I just took that secret key and I put it into this app called Beekeeper Studio. It's just like a really easy way to just plug in a hosted database. So that's what I'm using for this example. But yeah, essentially, that's all there is to creating a pipeline. You just pick a source, choose how you want to filter that data using the transform, and you just customize the SQL, you choose your sink, and then that's pretty much it. So when you're ready to deploy the pipeline, you just want to make sure that you name it. So for this, it can be like near demo. And then once you save it, looks good. And when you deploy, you'll see that there's different resource sizes available. So just to give you some insights, small is probably going to be good enough for almost everything that you'll need to do. If you ever need to increase the size, that's just going to basically make it way faster to backfill. So like, let's say, for example, you wanted to backfill all of Ethereum data and you needed to do it really quickly. If you were to just throw in a large pipeline, it would get it done much faster with the backfill. And then you can bump the sizing down to small just for the maintenance, right? So something to keep in mind, though, is that the higher the resource size, because it's more literal resources being used, it's going to cost more. So Typically, we do suggest starting with small just because it's already extremely powerful. It's capable for most use cases, and it's going to save you the most costs. So that's something to keep in mind, and then you deploy it. Now, I'm not going to deploy this because I actually already deployed a pipeline before. So I'm going to show you the one I already deployed just so that you can get an insight into what it looks like when there is data flowing through a pipeline. So this is one that I deployed earlier today. And as you can see, there's already records written, which is basically, data going into my database. And it shows you here which data set you used as the source, which sync you picked, and then the configuration. So this right here, this YAML file, is pretty much the code version of the visual pipeline builder you saw in the flow editor. So I picked the execution outcomes data set. That was that first block. This is the SQL transform I did. This is the second block. And then this is the Postgres sync that I used, which was the third block. So really, as you can see, at the end of the day, a pipeline is just essentially a YAML file. And the flow editor is just a way to visualize it and make it easier and just a more simple way to get started. So once you do have your pipeline live and you're pushing data into your database, I'm going to show you what that could look like in the database. So this is the Beekeeper Studio I was telling you about. I connected my hosted Postgres, and you get the table basically populated with the data from your pipeline. So you can look at the raw data just like this by opening up the table. But this is where it gets really powerful, is you can create queries to get specific information. So for this example, I am querying for recent activity, and this query basically provides real-time data of errors. So in a sense, it's like a feed of the most recent failed executions. And I did add a note I wanted to mention. So typically, when you're looking at a pipeline, let's say, for example, with Ethereum, records received is most of the time going to be the same, if not more, than records written. What's really cool about Near, as just part of the way that the functionality works, is you can see here that based on records received, there's actually more records written. And that's because Near data, it's not, or it is one record per block, but we actually get many transactions and events in a single block to emit. So although we get one record received in that block received, there's more transactions and events that actually get emitted. So that's why there's more being written into the database. So just a cool side note I wanted to mention, but this is an example query, right, where you're looking for recent activity, and this is what it's showing in the database. So another example query, this one is dApp health, where it's basically identifying, what are essentially the noisiest contracts, right? Which ones have high failure counts, because that is an indication that maybe that is a front end that's broken or something is wrong with a smart contract. So if there's a lot of failures, it's worth taking a look. So this is like a dApp health monitor. And this third one, this is gas wasted, right? So, even if there's a failed transaction, I believe on here that still burns gas. Correct me if I'm wrong, but that's just my understanding. And so this basically shows, which contracts are costing users money for transactions that still failed. So it's like a gas wasted query, right? So basically, to just sum it up, you have this database now with a table filled with these failures that you created from a subset of the Near execution outcome data. So pretty much, you're just funneling in specifically what you need, and then you're querying exactly what you want. So like as an example here, this is 10 rows, rather than a million or something like that. So that is, in a sense, how a pipeline is built. It's really, really simple and straightforward. You can also do this in the Goldsky CLI. And in the CLI, it would look kind of more like this. But it's really nice to just visualize what's happening. And so that was kind of why I wanted to show you the flow editor. Now, next up, what I wanted to talk a little bit about is Turbo. So Turbo is essentially the V2 of Mirror, and it's basically just better in almost every single way. It's got significantly higher performance, meaning it can now process a lot more records per second. So, really what was the need for turbo pipelines and kind of what was the genesis of us even needing to create it is that Mirror pipelines, they could support Solana, but it was just not really functioning as quick. The sheer amount of data was just insane. The speed was just crazy. So Mirror pipelines were just not really built for Solana. So essentially, because of the insane speed and large amount of data, we rebuilt our pipeline engine from scratch, and we used a different language. We basically made a new framework. And so turbo pipelines are now fast enough to handle Solana data, historical data, real-time data, but all of the data sets that are available from Mirror are basically one-to-one available for turbo pipelines now too. So that includes Near data sets. So you guys are lucked out. Basically, you get to use turbo to have really, really crazy speeds. So higher performance, that's obviously a really big benefit. The second one is there's TypeScript transforms. So basically the way you can transform the data, it's even more customizable now and flexible to really get you exactly what you're looking for. And a very cool thing is it's called dynamic tables, where basically you can update the lookup and you can filter without actually doing a redeployment. So you can make changes and pretty much do whatever you need to do in a much faster way with less headache. And just to kind of give you even more insights, this is our Turbo Pipelines page. I mean, there's a crazy amount of benefits. It's really crazy what this is able to accomplish. So take a look at the page. It's on goldsky.com products/turbo pipelines. And you'll see just all the different ways that pipelines can basically just streamline your experience. And data sets like Near are optimized for this. So definitely do recommend giving it a shot. And as far as creating the pipeline, it's super simple, right? Just like just like with the standard pipeline, you do new pipeline, same flow, you hit turbo. Only the difference here is it's just going to be a YAML file. So just to give you an example of another example that I made yesterday of a turbo pipeline with Near, this is essentially the YAML file that I used. And it's almost basically the exact same as the example in the docs here. The only difference is here, I hooked it up to like Postgres versus here, I did a black hole sync. And a black hole sync, it's basically not going anywhere, right? So you can just test it out and just kind of get an idea of, what exactly is happening if it's working. But every time you do deploy a turbo pipeline, you're going to get this page over here, which is similar to the previous V1 Mirror pipeline page, where it shows you the sources, it shows you the sync, and it shows you the YAML file of your configuration. You got your logs as well, just to give you some insights of what's going on over there. But the difference in the actual data is turbo pipelines, because it's a different language and it's just a different framework. The metrics are actually available on Grafana. So every turbo pipeline will get its own little dashboard like this, which is super cool. And I don't even know what half of this stuff means, but I think it's important to those devs that do. So definitely take a look, deploy a turbo pipeline, see what's out here. And, one thing you'll notice, I think, when you deploy a Mirror pipeline versus a turbo pipeline is, whereas a Mirror pipeline, could be a few minutes to deploy, turbo is basically seconds. It's just significantly faster. It's got way more options for customizability, and it's just all around, essentially the superior product. So that was the turbo demo. And that is basically it for today. Just kind of wanted to give you guys, a super quick rundown, little bit of history of what is indexing, what are subgraphs. Now it's basically how indexing all started out. And then here we are today. We've got, these real-time data streaming pipelines. Mirror's the V1, Turbo's the V2. Give both a try out the flow editor, try out the YAML file version with Turbo. And if you have any questions, definitely reach out to our support team. They're absolute gurus and super fast to respond. But of course, feel free to reach out to me too. I'm probably not going to be as technical as the tech services team is, but I can definitely answer any high-level questions, and would also love to just hear about what you're building out. It's always really interesting for me to learn about the use cases people are building out, the headaches that they have as they're trying to figure out, how to jump over obstacles. So feel free to reach out to me, send me a DM, happy to schedule a call, whether it's to help you out or to just chat. But yeah, basically all in all, indexing is a really cool way to streamline your process and, you know, basically abstract away the headaches of maintenance and, you know, building indexing from scratch. You know, you just use Goldsky, let us focus on that, and you just build a good user experience, focus on the branding and the marketing and getting people to use your product. You know, you don't need to worry about the indexing. We'll worry about that for you. So yeah, that's basically what I wanted to cover today. And I'm going to pass it back to you, Elliot. Oh, I think
Andrew,
you should mute. Yeah, there we go.
that was great. What a cool demo that you just did. I really liked you well, first of all, round of applause. You masterclass right there. But I really liked what you said at the beginning. How about how like it's indexing, although it can kind of seem daunting. I think it has maybe seemed daunting, especially in this industry for a while because of how things have gone. But it's actually a lot lower effort than RPC. You mentioned that. You're not going to hit your rate limits. You don't have to worry about like managing the RPC requests and the load balancing of it all and how it and kind of like that data pipeline on your side. And then that was so cool that you guys have, so you have the GUI that you can like move things around. You can actually see how the data moves through the pipeline. Is it correct that the YAML dictates what that pipeline looks like?
Yeah, pretty much that pipeline builder is essentially creating a YAML file in the background. And so that's just like the visualization. And in the YAML file, there's like the three components of source, transform, sync. And those blocks are just basically those components just visualized.
Cool. All right. Hey, I got a couple of questions for you. One, I was wondering, is there an API key to use? I think I saw that there was a CLI and you have like a login.
Yeah. So when you sign up for a Goldsky account in your settings, you generate an API key, and then you go to the CLI. It's super easy to install the Goldsky CLI. I'm pretty sure it's just like a single line. You basically install the CLI, you sign in with your API key, and then your project is connected. And then you can, you know, fully build in the CLI, or you can build in the UI on the web app. Either way.
Gotcha. We do have one question. Is there an MCP for this at all? Do you know if there is one?
Is that basically like an agent you talk to that builds for you?
Essentially, it's multi-context protocol. It's yes, in a way. It's like a way for agents to talk and communicate.
Yeah. So I don't know how much I'm allowed to talk about it, but
Okay.
let's just say we're trying to make it as easy as possible. And we have AI in mind, we have agents in mind. We're looking at, you know, maybe you can just talk to your pipeline. You know, maybe you don't even have to know what a YAML file is, you know? So right now, not necessarily, but it's in the works and it's something we are very tapped into. Our whole team, we're constantly playing with AI. I mean, our CEO is like vibe coding internal tooling for us. You know, I mean, it's crazy. We're very plugged into AI, so it is something that is top of mind, no doubt.
Awesome. We got a couple people. They're excited to use it. Somebody's building a financial product. About the financial, I think it's going to be very useful. They actually have a question for you. What would you recommend? Store my data in my own DB or outsource it to Goldsky?
Yeah, I mean, basically, when you're going to be using a mirror pipeline, either way, you're going to have some kind of database. So whether you connect your own, for example, Postgres, ClickHouse, S3, that could be your own database, or you can just create a hosted Postgres. So that's basically a database that we host on our end for you, but you still are owning the data because it's your database. But essentially, it is hosted by Goldsky. So you have options for that. It really just depends what's easier for your flow. I think at the end of the day, I would probably suggest you have your own database and you own your own data, especially if you're going to be working with any kind of sensitive material or proprietary data. Like you're just typically better off having your own database, you know?
No, that I totally agree. And actually, that was one of the things that I really liked about this presentation was, you know, we don't got to worry about the GraphQL of subgraphs of the past. You know, you can just stream this data directly into where you got to go. Well, cool, Andrew. This was great. Thank you for coming on. I think any last words? You got your socials there. Everybody give Andrew a follow. Follow Goldsky on there. Try out the product.
Yeah, and check us out on X too. We're Goldsky.io, and yeah, we're always posting new updates on there. And basically, we're plugged in to the ecosystem. We want to hear about what you're building. We want to meet you. So if you have any questions, feel free to reach out to me. Ping us on X, email us, DM me on Telegram, and yeah, we're just here to support you guys and want to be there if there's anything we can do.
Awesome. That's great. Well, thank you for coming on today, Andrew. I'm going to take you down now.
Sounds good. Well, thanks for having me on, Elliot. See you guys.
See you later. All right. That was awesome. That was great. I really like that workshop. I'm excited to try it out for myself, honestly. But just to round this all out, so that was the third workshop in our Innovation Sandbox series. We got a couple more coming up. Just want to make sure. I think the next one is going to be Building with PingPay on Friday at, 15 UTC. So I just want to remind everybody, since we got about 2 weeks left, I want to remind everybody of the tracks of the Innovation Sandbox. It's going until February 16th. You got about 12 more days, 3 tracks across the private web and private life, building consumer apps, or Web3 widgets, where privacy is a default across finance, assets, identity, and user data. I think that this presentation that we just saw with Goldsky and how you can stream data directly into your database, I think that becomes very relevant here in this track. AI that works for you is the other track. So it's leveraging Near's AI stack, the private cloud, private chat, shade agents, agentic payments, all of this to build autonomous user-owned AI projects. And then the last track is Open Society, from finance to the real world. So solutions that integrate stablecoins, real world assets, tokenized assets, near intents, or products that turn real world facts into reliable on-chain outcomes. I want you to think about oracles, leverage near intents. It's a really easy SDK that you can use. There's even, we have some skills that are out there that you can install right now. And you can find all of this, or here, very quick, just run down. You'll find that there's prizes, $3,500 per track. There's also going to be a $2,500 bonus for only on Near. So that will be the best use of Near's technology, leveraging the Near's tech stack to the best of its ability, because there's all these really cool things about it: yield resume, chain signatures, the account model, all these type of things. And then, of course, there'll be 2 cross-track bonuses of $1,000 each. You can find additional ecosystem bounties with Nova, who we just had a workshop on Monday. HotPay has one out there, and then we have Ping, who will be doing a workshop on Friday. You can find all of these resources, including the resources that Goldsky shared with us today, at this QR code. We're doing virtual workshops. We'll get some office hours up there. We've got, if you follow this link, you can join a Telegram and access all of Near's developer support channels. You have plenty of developer relations at your disposal. And then this is all accessible via this Notion Hub. If you need Near AI credits, so this is specifically, you're building for probably AI that works for you track, or the private cloud, or the private web track. If you want some Near AI credits, you can scan this QR code. You can get $5 worth. And then that's it. Thank you so much for tuning in and watching. You can scan this QR code. It'll bring you to the Notion Hub, and then you can go ahead and get started. Join the Telegram chats, form your teams, ask questions, get the help that you need, and let's start shipping. Thank you very much, everybody, for coming in. And I'll catch you next time.